So chapter 6, get into confidence intervals. This is question 22. Question 22, what we're trying to do is we're trying to find the margin of error for the given value of C, sigma, and N, where the confidence level is 0.90 or 90%. The standard deviation is 2.1 and the sample size is 100. So remember, the confidence level of 90% basically means from here to here is going to be 90%. Remember, this is your mean out here. Since you're doing z-scores, that's the mean is actually 0. So remember, the area of the curve, the 90% gets, there's 10% left over. So this is going to be like 0.05. This is going to be 0.05. So, you'd have your critical value over here and your critical value over here for that. So if I was using my calculator, if I hit second distribution, number 3, if I do there in the curve of a 0.05 left, this will give me my critical value of this 1.645. Also, they're going to be giving you a table. So at 90%, we're going to be given this 1.645. So actually, we don't have to actually do that math there this time. It's actually given to us. Anyway, to find the margin of error, we're going to be using this formula here. It's going to be that critical value for Z. It's going to be the sigma and the square root of the N. So to find the margin of error, remember, you'll have to have this formula written down so that you can do it. So the critical value at 90%, 0.90, is 1.645. So again, you'll have a table to pop that up. You're going to multiply that by sigma, which is the 2.1, divided by the square root of 100, which actually is 10. So we can actually do that math if we want to, or you can just put the square root of 100 there if you want. If you want to use the calculator for all that. So to actually find the margin of error, we type in the z-score, which is the 1.645, and we multiply that by, and I'm going to use the fraction button, number 1. I'm going to put that 2.1 on top and the square root of 100 on the bottom. And then we end up with then 0.345. So I think here they may ask you to round to 3 decimal places. So your margin of error would be 0.345 or 34.5%. So that's what we'd have there for the margin of error. Okay, what else do we have here? So question 23, we do the confidence intervals of the mean, but this time the standard deviation is unknown. Remember, if the standard deviation is unknown, this is when we use what we call t-scores. So we have that to keep in mind. So in a random sample of 12 cell phones, the mean full retail price is $456.50. The standard deviation was $215. Assume the population is normally distributed. Use the t-distribution to find the margin of error and construct a 90% confidence interval for the population mean. So again, a 90% confidence interval, remember, normally distributed means that the 90% is this area here, which means this leaves us 10% to be distributed out here and here. So this becomes 0.05 and this becomes 0.05. So using the table, we have to be using these 0.05s as our thing. But remember, we can also use our calculator. So if I do normal distribution, remember number 4 is how you find the critical t-score. So again, at a 9% margin, at a 9%, that's going to give us this 0.05 if we're using the calculator. But again, on your table, let me see if I can pull that up here in a second. Your degrees of freedom would be 11. So if we put that in, this gives us, we're just going to use the positive value. 1.796 would be our t value. Be our critical value for t. So this helps us find the margin of error. If we use a table, let me see if I can pull one up here. So notice how we have level of confidence is the 0.90, 11 degrees of freedom, you'd have this 1.796. If you're talking about the tails, I'd be doing a 0.05 for a one tail or 0.10 for two tails. So ours would kind of take on this look here if we did that. If I was using the calculator, I'd be using the 0.05 for a left tail. But here, notice how we can also use the 90% in the table and get that 1.796 as well. So to identify the margin of error, we have this formula that E is going to equal then this 1.796 times then the standard deviation of the sample, not of the population. So that's going to be the 215. And we're going to divide that by the square root of, since there's 12 cell phones, we'll divide by square root of 12. So if we put this in the calculator, clear this all off. So if we type in 1.796, that's our t-score, times then, I'm going to use the alpha F1 again. So the standard deviation for the sample is the 215. The standard deviation was 215. And then the sample size was the 12 cell phones, so the square root of the sample. If we do that, we get then our critical value, or our margin error is going to be 111. If we round that to the nearest tenth, that'd be 111.5 if we round to the nearest tenth there. So now to construct a 9% confidence interval for the population mean, we can use this right here. We have X bar minus C for the left endpoint and X bar plus C for the right interval. So to get the left interval, our sample mean was, so the full retail house was this 465, 456.50. So we have this 456.50. So 456.50. So if I subtract the margin of error, which is the 111.50, that'll give me the left side of the interval. If I do 456.50 plus 111.50, that'll give me the right side of this thing. So 56.5 minus 111.5. This gives 300. It's going to be our left boundary. And then we have 456.50 plus the 111.5. And that'll give us our right interval, which is 568. So that would be our level of confidence. We would feel like 9% confident that our values would be between 345 and 568. So last one I'm going to do is question, well, not last one, but next one I'm going to do is question 25. This is going to be from 6.4 confidence intervals for variance and standard deviation. So this is when we do these chi-squared strategies. Remember, chi-squared is not normal distributed in the sense that we are familiar with. Notice how, 0 is actually over here and it counts up from there. So keep that in mind, that 0 is actually over here, not in the middle like normal distribution. So we want to find chi-squared R and chi-squared L for the given confidence level of the sample size N. So we have this confidence level of 0.95 and N equals 18. So to find chi-squared r, we can use this 1 minus c over 2 to get the area of the curve there. So find the critical value there. So C is the level of confidence. So if we go 1 minus 0.95 divided by 2, that'll give us chi-squared r there. So if we go 1 minus 0.95 and divide that by 2, that'll give us 0.025. So it's going to be chi-squared r and chi-squared L. We're going to have 1 plus c over 2. Remember, it's going to be the area is going to be to the right. So we're going to be doing 1 plus 0.95 over 2 to get chi-squared L. So 1 plus 0.95 divided by 2. This gives us this 0.975. Now, what do we do with these values that we just found? So to find the actual areas under the curve, actually, these are the areas under the curve, I should say. To find chi-squared r, this is going to be my area under the curve. To find chi-squared r, I still got to use the table. So let me see if I can find my table for this. Let me pause my video for a second and pull up a chi-squared table here. So I'll put some of these tables in your folder as well if you want to print out some of these folders, some of these tables if you want, so you don't have to go back and forth. If you want some hard copies of these tables, you can. But this is the chi-squared one here. So to find chi-squared r, we actually have to use this probability here, the 0.025, because that's the area in the curve. And remember, the degrees of freedom is going to be 1 less than 18, so we have to be using a 17. 0.025 and the 17 would give us this 30.191. So cooperate with me here. So 30.191, I believe, was that. Let's see if I can find that table again. 0.025, 17. So yeah. And then to do chi-squared L, I got to use the 0.975 as the area, degrees of freedom. So chi-squared L is going to be the 17 there. That'd be 7.564. So that's how, again, we need to have these formulas here to do this. So to find chi-squared L, we can use this here to get our area of the curve. And then we just use the table for that. In the same way for chi-squared r, is we just use this formula right here and the table to do that. So that would give us our critical values, chi-squared r and chi-squared L. So chapter 7 gets to the hypothesis testing. This is going to be question 26 in your review. For the statement below, write the claim as a mathematical statement. State the null and alternative hypothesis and identify which represents the claim. So here we go. A laptop manufacturer claims that the mean life of the battery for a certain model laptop is less than 9 hours. That's the claim. So remember, the null hypothesis has to be an equality, and the alternative hypothesis has to be an inequality. So the less than 8 hours has to be the alternative hypothesis. So which statement here gives us the less than 9? So write the claim as a mathematical statement. So the mathematical statement would just be the mean life is going to be less than 9 hours is going to be our claim. Okay. So the next thing we pick up on is, So we didn't have to actually do the null hypothesis and all that stuff, but remember the null hypothesis, mu would have been greater than equal to 9, and the alternative hypothesis would have been mu was less than 9, and that would have been our claim. It would have been the alternative hypothesis. So the next question, let's see what we get into here. So question 7 is talking about the p-value for the hypothesis test. So the hypothesis, the p-value kind of is a shortcut to decide whether to reject that null hypothesis or not. So remember, if p is less than equal to the test value, we will reject the null hypothesis. So let's see what we have here. So the p-value is this 0.0976. First question, do you reject or fail the null hypothesis? Do you reject or fail to reject the null hypothesis at a level of significance of 0.01? So what we want to do is we want to compare the 0.0976. We want to compare that to 0.01. So basically what we're doing is we're comparing the second place value to the second place value. So 0.09 is greater than 0.01. So it is not less than or equal to 0. So since it's not less than or equal to 0, we actually fail to reject the null hypothesis. So our answer is either going to be A or B. So we fail to reject because the p-value is 0.096 is less than, no. We fail to reject because the p-value is actually greater than that. So that would actually be D, because you reject if it's less than, you fail to reject if it's greater than. So do I reject the null hypothesis at a level of significance of 0.05? So again, we're comparing this 0.0976. We're comparing this to 0.05. So what we're comparing then is the 9 to the 5, and also how that's still greater than. So again, this is a fail to reject the null hypothesis. So fail to reject, fail to reject. So it looks like D again. Fail to reject the null hypothesis because 0.96 is greater than the level of significance, which is the 0.05. So is there a third one there? And 0.10. I didn't do that one. So what about 0.10? C. So if we compare it to 0.10, 0.0976, how does that compare to 0.10? Now notice here, you actually have a number in the tens place. This number is actually a 0. This is a 1. So if you can do two test places here, 10 is greater than, so this is actually less than. So if it's less than, we are going to reject the null hypothesis. We are going to reject H sub 0. And the reason is because 0.096 is less than the level of significance there. So we would be rejecting the null hypothesis because the p-value is less than the 0.10. Okay. What else we got here? So lastly, we have a question 28, 7.3, hypothesis testing for the mean and standard deviations unknown. So again, when it says standard deviation unknown, that's going to be the t-test. So it says use a t-test to test the claim about the population mean at the given level of significance using the given sample statistics. Assume the population is normally distributed. So our claim is the mean is not equal to 25 at a level of significance of 0.01. So the sample statistic is 22.3. Our sample standard deviation was the 4.9, and our n was 11. So again, we could find that the critical value of the test statistic using the formula over there, x bar minus mu. So that's going to be this 22.3 minus the 25. And we're going to divide that by the 4.9 divided by the square root of 11. So again, I'm using my calculator, see if I can get that back up here. Let's see, got a lot going on here. So I'm using alpha F1, but this top is going to be this 22.3 minus the mean, which is 25. On the bottom, I'm going to use the alpha F1 button again. And I have the 4.9 and then the square root of 11. So it gives our t value, which is going to be then the negative 1.828. So it's the p-value of this test statistic. So to find the big p-value, I think we could probably use the testing here. So let me pause a moment and see what we can come up with for that. So I think they actually rounded this to 2 decimal places here. So this is going to be negative 1.83 is going to be my, because it does say round 2 decimal places. So negative 1.83. So we want to find the p-value of this test statistic. An easy way to do this is, again, use your hypothesis testing on your calculator. So if you use the stat button, if we go over to test, that's that third one over. Number 2 has actually got the t-test. So again, we're using the stats, not the data. So our population mean was the 25. Put that in. The sample mean, this actually should be X bar here. Should be 22.3. The standard deviation is the 4.9. The sample size is 11. And this was not equal to 25, so we use that. So this is one of those two-tailed normal distributions. So if we do that, it should give us our p-value. So our p-value is going to be this 0.097. So if it says round to 3 decimal places, so 0.098. So what we want to do is we want to compare that to, what do we want to compare that to? What was our alpha was 0.01. So what we want to do is compare that to 0.01. So how do we compare that to 0.01? So that's how this is going to be greater than. So notice how, since this is greater than, we're going to fail to reject the null hypothesis. So as we do this again, remember, if we do our hypothesis testing, our null hypothesis is going to be mu, and our alternative hypothesis is going to be mu. But remember, the alternative has got to be the inequality, so it does not equal 25. That's where our claim is going to be. And then our null hypothesis is going to be the equal to 25. So as we do this, what we end up picking up on here is we're failing to reject the null hypothesis. So remember, when we do this, we also have to make these interpretations. So if we fail to reject the null hypothesis, and our claim is the alternative hypothesis, there's not enough information, there's not enough evidence to support the claim, is what we conclude. So it's a good idea to write this little table down, because that gets a little confusing. So if we fail to reject it, there's not enough information to support the claim either, since it's the alternative hypothesis. So it can be true or it can be false, but we kind of get there with that. So again, we can use the p-value and we can compare that to our level of significance, which is the 0.01 up here. And since 0.98, that 9, so like if you want to go to 2 decimal places, 0.09 compared to 0.01, 0.09 is greater than 0.01. So this means that we are going to fail to reject the hypothesis, because it's got to be less than to reject it. And since we fail to reject it, this takes us in our table here. And since our claim was the alternative hypothesis, there's not enough evidence to support the claim, is kind of where we go with that. All righty. So I'm going to stop there with the review. Hopefully you found that useful as you prepare for your final.